Hello, today we'll be continuing with chapter 1. We're starting 1.2 today. This is exponents. So you can see when you write exponents, you always have a base, so the base here is x, and you always have an exponent. So if I write x to the 7th, okay, the base is x and my exponent is 7. Okay? Let's look at some properties of exponents. Okay, if you're multiplying exponents, then what you want to do is add the exponent part. Okay, so x to the m times x to the n is x to the x to the m plus n. Okay, let me give you an example of that. So if you look at x to the 2nd times x to the 3rd, you add the 2 and the 3, and you get x to the 2 plus 3, which is x to the 5th. Okay? X to the m over x to the n, when you're dividing exponentials or exponents, you subtract the exponent part, you get x to the m minus n. So if I had x squared over x to the 3rd, okay, 2 minus 3 is x to the negative 1. Okay, again, you always do the top exponent minus the bottom exponent, so that's x to the negative 1. And you can write x to the negative 1 as 1 over x. Okay, x to the m to the n, so when you're taking an exponent to another power, you say x to the m raised to the, x to the m raised to the n. There's a little bit of a, the font got a little messed up there, but that's x to the m raised to the n, and that's x to the m times n. Okay, so if you have x squared and x to the 3rd, oops, what am I doing? X squared raised to the 3rd power, 2 times 3 is 6, so that would be x to the 6th. Okay, and x times y to the n, you can distribute that exponent inside, so you get x to the n, y to the n. Okay, just like if I have x, and that works for numbers too, like if you have 2x raised to the 3rd power, you want to take that 2, or that 3 rather, and make sure the exponent of each of those becomes, make sure the exponent is distributed to each of those. So you get 2 to the 3rd, which is 8, x to the 3rd, right, is x to the 3rd. Okay, and then x to the n over y to the n is x to the n, or x over y to the n is x over n to the y to the n. And then again, the same thing, I just distributed that there. Right? So if we have something like 5 over x raised to the 2nd power, you need to make sure you distribute that to both. Okay? So you got 25, 5 squared is 25 over x squared. Okay? And then 25 over x squared. Usually we like to leave it as positive exponents, but you can also, you might also see it like this, x to the negative 2. Okay? So hopefully you've seen this before. Okay? I use some negative exponents inside here. Look at this one here, x to the 0. Anything to the 0 is 1. X to the negative 1 is 1 over x. So it's kind of like when you have a negative 1 here, when you have a negative in the exponent, you got to move that down. And that's why it gets 1 over x. So you move the expression down and you leave the exponent the same, you just make it positive. X to the negative 2 is 1 over x squared. So that means x to the negative n is 1 over x to the n. Okay. So I'll give you an example. Let's look at this one. 3 to the negative 2 is 1 over 3 squared, right? Can you move it down? Make the exponent positive, and that's 1/9. Okay. You can look at other, your book has other examples, and you can think of an example for each of those. Okay. There's a note of caution here that when x is 0, so when x is 0 here, and when, if you have the x is 0 and you have a negative number here, let's say -2, both of these are undefined. So 0 to any number, let's say 0 to any number, undefined. Okay, 0 to the 0 does not exist. 0 to the negative exponent does not exist. Okay, so x cannot equal 0. Okay, so that's a little caveat there. So exponents work like that, except for when x is 0. All right, let's scroll down and do some examples. So let's simplify these. X to the 5th times x over x squared. So for order of operations, right, first thing we're going to do is multiplication here. So I got x to the 5th, and there's a 1 here, right? If there's just an x, it's just a, if it's just x by itself, the exponent is 1. X to the 5th times x to the 1. So we know from our rules here that we have to add the exponents. So 5 plus 1 gives me x to the 6th divided by x squared. And if you need to write that, if you need to write it out, no problem, write it out. Okay. X to the 6th over x squared. So now you know that you have to subtract from our rule over here. Which one is it? This one. Okay, when you divide exponents, you have to subtract. So it's x to the 6th minus 2, which is x to the 4th. Okay. And then we have x cubed squared again. Okay, so this is actually, let me change my the color here, x to the 3 raised to another power, so that's times 2, and then raised to another power, so that's also times 2, so that's 3 times 2, which is 6, times 2, which is 12, so this whole thing just becomes x to the 12th. Okay, let's do another one here. So 2 over 3 raised to the -2 power. Okay, so what am I going to do here is, this negative exponent tells me to move it down, right? So this actually becomes, if you look at this rule here, x to the -n is 1 over x to the n, so that's 1 over 2/3 squared. Okay, 2/3 squared, we know this rule here, okay, this one here, x over y to the n, is, let me erase this here. We know this rule here, x over y to the n is x to the n over y to the n, so that's 2 squared, which is 4, divided by 3 squared, which is 9, and then 1 divided by 4 over 9, you flip it, so it's 9 over 4. Okay, so 2/3 raised to the -2 power is actually 9 over 4. Okay, we can generalize this and say when x over y to the -1 is, you can say y over x, y to the 1 over x to the 1. Okay. In general, when you have x to the -n over y to the -n, right? I mean, what am I doing here? How did I know that? Because it's x to the -n over y to the -n. So let me derive this for you. Right? And then from above, we know that they move down. Like, so the x to the -n is going to move down. It's going to become positive, x to the n. And then y to the negative moves down within the fraction, right? So it actually becomes 1 over y to the n. But when you have a fraction inside the fraction, you always flip the denominator, right? So 1 over y to the n is actually y to the n. Okay. If you didn't understand that derivation, that's okay. The takeaway message is that it's just y over x to the n. Okay, but if you can If you know the rules in between, that's good. If not, don't worry about it. Basically, what you want to remember is this. Okay? So anytime you have negative exponents and fractions, you have to flip the fraction and make your exponents positive. Okay? Just like I did here. Let me do another example. If I have 1/2 raised to the negative 3 power, how am I going to do this? Well, okay, I say to myself, I know it's negative, so I know I have to flip this and then make this positive. So you flip it, you say 2 over 1, then you make the exponents positive. Okay? 2 cubed is 8, 1 cubed is 1, any number over 1 is itself, 8 over 1 is 8. Okay? So that's just another example for you. Alright, let's go to roots. So if I say here the nth root of a, the nth root of a actually means the principal nth root of a. Principal here means positive. Okay? Just like if you look at square roots, right? If we look at the square root of 4, the square root of 4 is actually 2 and negative 2, isn't it? Because 2 squared is 4 and negative 2 squared is 4. But when I say the principal root, I only want that positive number, right? It means the positive root. Yes, square root of 4 is 2 and negative 2, but we refer to the positive when we're talking about the principal nth root, okay? So it says write and evaluate the fourth root of 81. So the fourth root of 81 is, let's see, so I'm thinking to myself, what number do I have to multiply 4 times to get 81? Well, I know 3 squared is 9, so let me think about that, right? 3 times 3 is 9. If I add another 3 and multiply another 3, I get 2 9, so that gives me 81. So the fourth root of 81 is 3. Again, we're only looking at the positive root. Fifth root of negative 32. Okay. So the fifth root of negative 32. Okay, so you want to think to yourself, let me try 3. Well, I know if I add one more 3 here, it's going to be bigger than 81, so it can't be 3. 1 can't work because 1 squared is 1, squared is, to the third power is 1. So maybe let me try 2. So you say 2 times 2 times 2 times 2 times 2. So 2 squared is 4. 2 squared is 4. 4 times 4 is 16. Multiplied by another 2 is 32. Okay, so the fifth root of 32 is 2, because you had to multiply 2 5 times to get 32. Okay, let's scroll down. Powers of the form 1 over n. X to the 1/2, so we write that as x square root of x. X to the 1/3 is the cube root of x. So you want to put the cube root inside that little area there. Be careful, this is not the same thing as this. Okay, so if you write your 3 on the outside, that's something different. That means that it's 3 times the square root of x. This one is saying cube root of x, okay? And then in general, the nth root of x, or x to the 1 over n is the nth root of x. Okay. Now we're going to combine these roots with our exponent laws. So 4 over 25 raised to the 1/2 is, again, 4 to the 1/2, which is square root of 4, divided by 25 to the 1/2, which is square root of 25. Square root of 4 over square root of 25 is 2/5. Okay. 16 over 81 raised to the 1/4, that's 4th root of 16 over 4th root of 81. Okay, 4th root of 16 is 2, like we saw up here, right? 2 times 2 times 2 times 2. I get 4. 4 times 4 is 16, so this is 2. 4th root of 81 we saw earlier was 3. Okay. Let's look at this one. Oh, now I have a negative here, right? So it's negative cube root, so remember 1/3, so again I'm putting this exponent inside here. So you distribute that exponent. So you do 27, it's the cube root of 27, but that exponent stays on the outside, okay? Divided by cube root of 8. So 3 times 3 is 9, times 3 is 27, cube root of 27 is 3, cube root of 8 is 2, and you have a negative on the outside. And you can actually put that negative on the top or on the bottom or on the outside. Okay. And then we have negative 27, the cube root of negative 27. Excuse me. So if you have negative 27 raised to the 1/3, you can distribute that negative. It's going to become the cube root, okay? But it's going to become the cube root of negative 27, okay? The reason for that is because that negative is connected to that 27, right? So remember our order of operations, parentheses, then exponents. So you want to keep those parentheses together, okay? And then we know that negative 3 times negative 3 times another negative 3, right? 3 times 3 is 9, times 3 is 27, but when you have negatives, it becomes positive 9 times negative 3, which becomes a positive, or rather a negative 27. Okay? So this is equal to negative 3. Okay? Let's look at this one. Now I have fractional exponents, x to the m over n. So you can write this as, so you have to think about it like this, and I know people always confuse this concept, so let me break it down further. See, this is x to the 1 over n times m, right? So m over n is really 1 over n times m, in which case you say, oh, I know 1 over n, that's the nth root of x, and then the m is on the outside. Okay, that's what they did here. Or you could write it like this: x to the, you can say m over n is m times 1 over n, and then you can say, oh, it's x to the m, and I know that's the nth root, so you change the 1 over n to the nth root, and you can put the x on the m on the inside. So it doesn't matter whether you put the m on the outside or the inside. Just be careful not to switch your m's and n's, right? Whatever number is in the denominator, that goes inside the root sign. Okay, so let's write that here. So I'm going to write denominator inside root sign. Okay, and hopefully that'll help you remember that whatever number is in the denominator goes inside the root sign. Let's look at this one, 16 to the 3/2. Now you don't have to do this derivation. I just wanted to show you where that rule comes from. Let me complete this here. X to the, I did, okay. Alright, let's do this, whoops. Let's do this one, 16 to the 3/2. So 2 is on the denominator, so that goes inside here. Now you don't have to write that 2, it's just square root, okay? Right, you know that goes inside, and then it's 16 to the 3rd. Now if I put 3 on the inside, I gotta count, figure out 16 to the 3rd and then take the square root of that. It's much easier to put the 16 on the outside because I know, right, so technically it's written like this. You can put the 2 there, but we don't need to. I know the square root of 16 is 4. And 4 cubed, 4 times 4 is 16, times 4 is 64. Right? So you can use your calculator to, if you don't know how to do numbers in your head. Okay? So that is 64. Let's do this next one. Now negative 8 to the 2/3. Where's my blue pen? Alright, so negative 8. So that's going to be cube root, because the 3 is in the denominator, cube root of negative 8 raised to the 2nd power. Okay. Again, negative 2 times negative 2 times negative 2, that gives me negative 8. So it's negative 2 squared, which gives me 4. Okay. So the answer to the first one was 64, and the answer here is 2. Okay, well, the answer here is 4, rather. Okay, let's look at... Then you can read this about your graphing calculators. Okay, so there's just telling you to be careful looking at negatives. So whichever way it works, remember it for evaluating negative numbers to fractional powers in the future. Okay, so you can read that. Alright, there was one note I wanted to tell you, that you have to be careful about roots. Okay. So when you're doing square roots, and I see this people making this mistake a lot, so that's why I put it here. If you have the square root of a times b, yes, that's the square root of a times the square root of b. No problem. But the square root of a plus b is not equal to the square root of a plus the square root of b. Be careful. Okay. When you have a plus or a minus, you cannot split up those two and put them outside of the square roots. Okay, let me just give you a simple example. Square root of, let's say, let me think of a good example for this one. Alright, so let's say 4 square root of 4 times 16, right? You're going to say, oh, that's the square root of 4 times the square root of 16. Square root of 4 is 2. Square root of 16 is 4, so you get 8. And then square root of 4 times 16, well, 4 times 16 is 64, and we know 8 times 8 gives me 64. So the square root of 64 is 8. So this works, right? 8 here on the left side equals 8 on the right side. But for square root of a plus b, square root of 4 plus 16 is not equal to the square root of 4 plus the square root of 16. Look at this. This is 2 plus 4, which is 6. This is the square root of 20. Okay, square root of 20 is what? It's going to be less than 5, because square root of 25 is 5. So let me just plug it into my calculator. It's 4.47, right? So it's not 4.47. It's not. Oops. Let me write this meter. It's not that easy to write with the computer pen. Let me see. 4. So we said 4.47. Okay, roughly. All right. So these are some active learning problems you can do for section 1.1 and 1.2. And if you have any questions, send me an email or stop by, and I can answer your question for you. Okay. All right. Thank you for watching.